social distancing, you say? The future is watching. Welcome to Opcode Virtual Summit.
Microphone. Hi everyone, and thanks for joining us for this first edition of Opcode Virtual Summit. So as you all know, a lot of security conferences have been cancelled last month. Likely it's going to be the case for the next months. So that's why I thought like 2 weeks ago it would be a good idea to come up with virtual summit. I'm sure we're going to see more and more the next weeks and months. So for cybersecurity, as far as I've seen, I didn't see anything yet. Like I said, like the ID just was born just 2 weeks ago. And since I also said that I won't do any opcode in 2020, I guess I changed my mind. Virtual edition would be something like quite interesting, I think, especially what's happening at crisis work with the like security adapting very quickly, and that will be a part of it. Past 3 years, Opcode was always physical conference. Sometimes in once in Nairobi in Kenya. So yeah, that's pretty much it. So welcome virtual summit of Opcode. I would assume you're watching this type of audio part. Yeah, if you are watching YouTube, I would assume chat. If you see any issues, like I said, this is the first time. This is live. I don't think we would have any problem, but just in case, we never know. Okay, let me know what about now. Maybe it should be better. Yeah, so that's it. So let me know if you still have issues for the audio. But yeah, so if you have watching this on YouTube, you should have the chat room on the right. And so if you have any questions or any comments, you can mention it on the site. If you're going to be on Twitter, so the official hashtag is OPCDE 2020. And we also have okay, perfect. Well, a little tip, if you ever do audio, like don't try to put some filter at the last minute. But yeah, we also have an IRC server in place. So just for that, you're more than welcome to join. And the material of the conference is also going to be available on YouTube after, obviously, and also on GitHub. That's where we're going to have all the slides. So yeah, so that's pretty much it. Like I said, this is also a first edition. Like some issues are expected. So yeah, if you spot anything, don't hesitate to let me know in the chat. And yeah, we will see. Like maybe that's something that will come once a month if everything goes well, and if like if it's getting like some good traction. And the format, unlike the previous conference, so the format of the conference and the DNA was always to have something very short, right? To have like a 2-day conference, single track, to avoid people to get distracted with like too many things, and to have a purely focused content. It's going to be the same thing here. So the content is like going to be like purely technical, and on top of that, on top of having like technical content, the format here, as you have seen, is not over multiple days. It's just alpha day, so it's from like 9 a.m. Like San Francisco time until noon, just to have like around like 4 presentation every time, to not be like too overwhelming. Because one of the things also with traditional conferences, even as a speaker, as an attendee, it's very like time consuming. Like you almost have to book like 1 full week to attend the conference, or even to speak to a conference. And you speak for 1 hour, and that's pretty much it, you know. So it's not very like time efficient. So that format is going to be more compressed and maybe like more regular. And yeah, that's pretty much it. So just an overview on the agenda for today. So our first speaker is going to be Mazin Ahmed, who is going to talk about building pentesting tools using serverless functions. I guess more and more people are using like cloud, so that should be like pretty interesting. Yes, I see in the chat. Did Greg cancel? Yeah, well, I just talked with him. I was like, I'm gonna tell everyone that you had passport issues again, as a joke. But yeah, so Mazin is gonna be a replacement. But yeah, unfortunately, Greg was not able to make it for this edition. But maybe for the next one, you know. And our next speaker is going to be Joxean Koret about alpha-automatic compilable source code recovery. So it's going to be a reverse engineering talk that should be quite interesting too. And then we have Katie, JC, and Andrei from Microsoft who are going to talk about Purple Teams. So they're going to share their experience at Microsoft. And last but not least, so we're going to have Charles from Nairobi, who is also going to be with us to talk about black box reverse engineering. I mean, he will give more details in his presentation because I don't want to spoil it. But that's a pretty good talk also. But yeah, that's pretty much for the introduction. Thanks again. Yeah, if you have any questions or anything you want to share, like don't hesitate to like chat or like post any comment in the chat. That's also what we're gonna use for the Q&A session. And yeah, that's pretty much it. So let me just get ready for our next speaker, who is gonna be Mazin. I just unmuted you. Can you hear me okay, Mazin?
Hey, can you hear me?
Yeah, that's perfect.
Perfect.
Yeah, you can start by sharing your screen, and I guess we can get started.
Perfect. Just one moment.
Yeah, no worries.
I'll be ready.
Yeah, that looks good. Let me put it here. Screen view. Pen testing tool. Yeah, that's perfect.
Okay, so I may start?
Yeah, go on. Thanks,
perfect.
Mazin.
Anytime. So thank you everyone for tuning in. So today's talk that I'll be presenting will be about using serverless for building penetration testing tools. Before we start, a little bit about me. My name is Mazin Ahmed. I am a freelancing penetration tester and information security specialist. I also founded Fullhunt, and hopefully the next generation vulnerability intelligence platform. Before that, I used to work as a security engineer at ProtonMail, and I'm a occasional bug bounty participant. In 2014, I used to be in the top 10 at Bugcrowd. I was acknowledged by Facebook, Twitter, and other companies for finding security vulnerabilities in their platforms. I'm interested in web, mobile, infra, security, in Wi-Fi visions, software automation, DevOps. And yeah, you can reach me out at mazinahmed.net. So the agenda for this talk will be a quick introduction and the background about this research. Then we're going to talk about the providers, how we can connect serverless and pen testing. Hopefully there will be demos and the conclusions, and we're going to jump up to the questions at the end. This presentation was supposed to be an interactive one, but I don't think that we are going to make it. But so we'll try to go with the flow. All penetration testers or all red teaming operations should have an red teaming infrastructure so that they can engage and build their attacks, build their testing, and etc. And one thing that we typically do is we have a number of servers that requires more time for maintenance, more time for building, and time for monitoring in general. It's something that is required, but also consumes a lot of time and a lot of effort. And the thing that I have been seeing with serverless, there is a huge opportunity in um, some sort of automating a lot of work that we can have in our penetration testing, and having it in a way that can be novel, in my opinion. And I have been doing this in my penetration testing projects, and I can see that it's a trivial way to automate stuff. Before we start, so serverless essentially is a technology that allows us to host our applications without worrying about maintaining servers or web servers or these type of things. We just push our code to the provider, they host it for us, they deploy it for us, they configure it based on our configurations, of course. And that's it. We don't have to worry 3 months from today about issuing or renewing our certificate, or I can go on with all this, but the concept is simple. You push the app and that's it. They take care of everything and you use it. So you can imagine serverless as a fancy word of kitchenless. It's like having a kitchen, but it's takeout. The biggest providers are Azure, GCP, and AWS, of course. And they all have the same functionality in different namings, but I'm talking about a different one in this research or this talk. The platform is called Zeet. It's a fully serverless platform. They do not provide much services. Like they're not a big provider like Azure or GCP or the AWS, but their service is quite cool. I have been experimenting it for the past year, and I can rely on them for this. So serverless and pen testing. The first research that I have seen for serverless for implementing serverless in our penetration testing was done by MDSec in 2018, and this research it was quite good start as a start, of course. And what they have been doing, they were implementing a simple callback using serverless. And then at the end of the research, you can find a URL that can be embedded within an image, so that when people open the URL and then it's embedded within emails. So when people open the email, we get a callback that someone opens an email. That's essentially their research, their implementation. And 2 months after the research by 2 months after the research by MDSec, RobNop released another research that is discussing how to use Zeet in different scenarios or use cases. Back then, I think it was Zeet version 1, and they supported Docker for serverless. So you can host your entire application and expose it into a certain port. Around it was 3000, and what's being executed within the in the container, you can expose it within this within a middleware app that is serving on port 3000, and you can literally have every single application you have in mind there. And it was quite cool. He showed multiple use cases, and then Zit disabled or removed this functionality of using Docker, and now they support majorly applications, Node.js, Python, Golang, and a lot of other services, but you cannot fully customize it as it was back then. It was a cool research. I will show a couple of things that he published later. That was in November 2018. And from there, I published a tool called XLess. It's the serverless blind access app. This tool can be used in order to build a quick serverless application that can be triggered, a quick blind XSS application that can be triggered when exploiting blind XSS vulnerabilities. It hosts the payload for you. It executes it. It returns the payload when it's executed, and it serves back the response to you with the notification channel. In the tool, I was using Slack. You can customize it to use whatever notification channel you would like to use. It was a cool tool. You can literally deploy a blind XSS app with and not worrying about it for the next year in like 2-3 minutes. And for me, as example, I deployed my XLess instance. The last update was like 6 months ago. I don't recall I have done any maintenance about it for it. Demos, I think I have images and screenshots. Hopefully it will be next. So the first use case was Nmap. It was when Zit supported Docker. It was so, and RopNap used like built and Docker container that have Nmap that he installed Nmap, and then he wrote a quick Node.js interface or middleware app that can take the user input and then execute it in shell, calling nmap and then returning the response. You can see here he just curls the URL that he had, and the return was the response for the open ports. The entire port scanning was not done by his IP address. It was done by the serverless application, serverless provider here, by now.sh. Also, you can use serverless as your notification channel. We all have this scenario where we are conducting a phishing engagement or phishing exercise, and we would like to get the credentials sent back to us. And then we have to set up our servers and having the notification and testing the notification channel and making sure that it's working correctly. But with serverless, you can automate this quite quickly. Here, you can have this example. I have a notification channel app that I wrote. This is a very small one. And whenever like a user triggers it, you can see that it sends me back the IP address that sends it, along with the post data that was sent with it. It's a quick one, quite helpful. I don't have to worry about the maintenance. Phishing, the best part about serverless, in my opinion. This example, I am hosting a phishing page. Of course, it says phishing, but you can just imagine it as an evil, fancy phishing page. And the phishing page that is hosted here is not done by it did not take a lot of time for me. I just literally click now deploy, and the phishing page is up with a new URL. Yes, you can say, Mazin, if this is not fancy, you have the URL, you can just block all the now and see the instances from the domains, and you are secure. But that doesn't, it's not the case, because in serverless you can customize it into having it returned via different domain name. I will show you next. Before after this one. So when someone here, this slide, enters their username and password, you can have them send the page, the responses of the credentials to your notification channel. In this case, it was Slack. And for me, I don't have to keep a database. I don't have to have anything. It's fully stateless setup. And malware dropping. The iCar file that I have here is hosted in serverless in Zeet. Zeet also can be utilized as a CDN, where you can host your images and your files, of course, your malware in this case. And every time it generates a new URL, and the fact that it's using a cloud provider, it's not something that you can block, because the IPs are dynamic. You cannot differentiate between normal IP addresses and malicious one, if you can say. And here you can see that I'm hosting it in Mazin.xyz, and this is the beauty of our current state of cloud providers. You can do a lot of modifications and customizations at that. And yeah, so you can host your malware with a different domain name, and the setup for me to have this is like, I don't know, 5 minutes. It's not about the novelty of having this being set up. The cool part about this is to have it set up in 5 minutes or 3 minutes. This is what I like in serverless and the current providers. Also, another use case here would be using serverless for cross-site scripting exploitation. Before serverless, we used to have something like this. We test like a web page with script, alert script, and alert one script, and if it shows a pop-up, then hey, this is a cross-site scripting. But it's not that advanced. It's not. We are like in 2020. This is not. This should not be the way to test that. Because one reason is, let's say that you are searching, you are testing, let's say, a search input, and it's not vulnerable to cross-site scripting. Then you just pass it and mark it uh, as secure in this case. But what if this search functionality have a backend admin panel that is showing all the search queries that was done by customers in this case, and this functionality is vulnerable to cross-site scripting. In this case, it would show an alert with like this, but me as a penetration tester or a security tester, I wouldn't be able to find out whether this is vulnerable to cross-site scripting or not, because I don't know. I don't have the metrics or the triggers to know that. So people came along and developed something like this. This one is by I Am Mandatory. And this platform, you can use a generated cross-site scripting payloads with different URLs, and you can send it to the website, and whenever it triggers, you receive an email with all of the details that was collected from that particular user agent or session. It was good, but it's it's a hosted service, and if you would like to have this in an environment that you can fully control, this will not be the best option. Although XSS Hunter have their own version of self-hosted application that you can host it on your server, but come on, it's a lot of work. Uh, for me, as someone who would like to have this deployed, I would prefer something that is quicker. And I developed. So this is the report that is that you can receive in email whenever there is an XSS payload that is fired with the URL, with the IP address, and all of the related information. And this example that I developed here with XSS, you just provide this URL as an input, and you get a full report like this with all of the data that was collected in Slack. Or you can customize it into your own notification channel. Also, another use case would be canary tokens. It's not the same one, same canary tokens by Harun Mir and Things Technology. It's majorly the same concept. You can generate an out-of-band canary URLs or out-of-band callback URLs. You can supply them to whatever you want, and then whenever it triggers or sends an HTTP request, you can have them sent back to your notification channel. And it's something that you host by yourself. You don't have to worry about all of the other things in terms of maintenance and etc. So conclusion for today and for this talk, serverless is awesome. We can clearly see how you can automate a lot of cool things in minutes. And there are a lot of potential usages here. And the overhead for maintenance is 0. And having a controlled server in your network that manages everything is a must for good operational security. In the end, if you are doing penetration testing for an entity that is quite sensitive and you don't want to have the credentials that are being sent to Slack, your Slack workspace, you might need to have a control server. But from a research perspective into the usages of serverless, you can clearly see that the usages for serverless is quite cool. And that's it. Thank you, everyone. We can start with the questions.
Thank you, Mazin. Yeah, let's see. Do you guys have any question in the chat? While we're waiting for some questions, actually, regarding serverless, which languages can be used to do serverless application? I know you can use .NET and Node.js. Is there like new languages you can use to make a serverless application now?
Yeah, so it depends on the provider. So Z supports, before it used in V1, supports Docker. So you can literally deploy whatever image that you have in mind and it would work. You don't have to worry about the language. But now it's limited to the language they support. The languages they support are Node.js, Python, Golang, I think .NET. I'm not sure about it. And
which cloud provider was that?
Yeah, Z.
Okay.
Yeah, and AWS supports Python, Node.js, and Golang. Azure supports a number of them. I haven't used Azure before, Azure functions.
Yeah, I think they have Python, but I think it's in beta. I don't know if they rolled it out yet.
Oh, really?
Yeah, it was mainly like .NET C#, I think, because they have like the web app and the Azure functions. But for Azure functions, I think you can only do Node.js and .NET. But I think at some point they were working on Python, so I don't know if it has been released yet or not.
I didn't know that. I thought because Python and Node.js are almost like the de facto for serverless. Like since AWS started, I think it was the first company, one of the first companies that started serverless. Python and Node.js were the first languages, but I didn't know that SU did not support it yet.
Yeah, that will make sense. Someone in the chat is asking if one can create canary tokens on Zaid for free.
Yeah. So that's the cool thing about Zed. It's fully free to one thing that is in Zed and is not on in Azure or AWS and GCP, that you don't have to provide your credit card details. You just create your account, you have the setup on your laptop, and you can deploy it for free without all of the hassle. And for the canary tokens, you can just say git clone xless, the application that I have, and then now deploy, and you will get a URL, and you can use it for canary tokens, and it's for free, of course.
And for if you want to do canary tokens, I think you can also go on canarytokens.org, where you can create it for free.
Yeah, I would totally use the one by things, not the one by serverless. That one, yeah.
Yeah, so you don't have to deploy like anything. Which is like pretty. It's very convenient.
Yeah.
I've been using it a lot.
Yeah.
It's pretty good.
Yeah, but the way to customize identification
channel.
Of
course.
Yeah, that's probably the cool thing about that.
Another question is, how is it competitive in terms of pricing? Let's say Lambda versus ECS.
Lambda and so Zip is free until you reach some sort of a limit, and it's quite high limit. Lambda, AWS Lambda, I think you can have almost 1 million requests per month for free in the free tier. When you create your account for the next 12 months, from creating the account, you have like the free tier, and it allows you to have 1 million requests per month. And after that, you are charged per execution, per request, and per execution time. So if the request is processed in a couple milliseconds, it will only charge a lot. You can easily have this in like $2 a month, unless you are hosting a heavy web application or execution for that part. So it's quite competitive comparing to have that. And for me, I happen to deploy a number of servers and I forget about them. And of course, I will be charged every month per allocating that server. But in Lambda and serverless, Lambda, Zet, and all this, I'm only charged by execution. So if I have a server, like I have an application, I forget about it for 6 months, I wouldn't be charged unless I'm using it, which is pretty cool.
Yeah, I think most of cloud providers have a quota before you get charged for serverless, right? Because they're trying to get people to use it. So
yeah. But AWS is quite like they have you hooked onto their platform, and once you are hooked, they charge you badly on that.
Yeah, that would make sense. Someone replied in the chat. So for Azure Functions, they support C#, JavaScript, F#, Java, and Python. So I guess Python is not in beta anymore. That's pretty cool. Yeah.
Yeah, that's cool.
That's quite good. Cool. Do you guys have any more questions? I mean, I guess by the time they get if we have any more questions, it's gonna be like 30 seconds delay. So, but yeah, let's. Okay, I guess that's it. Anything you want to add?
I'm perfect from my side.
Okay, cool.
Yeah. So thank you, everyone.
Well, thanks for you and for your presentation. So Mazin presentation is going to be available on GitHub after. And yeah, so let's have a short intermission and we'll continue with our next speaker, who is going to be Joxean, to speak about like source code recovery.
Social distancing, you say? The future is watching. Welcome to Opcode Virtual Summit.
Hi, and we are back. So let's continue with our next speaker. So let me check this thing here. I guess for next time we probably need at least like 3 screens to get yeah. Can you hear me, Joxean?
Yes, I can.
Okay, perfect. Yeah, so we're running a bit early, so we can start now if you're ready.
As you want.
Yeah,
I
perfect.
don't have any problem.
Awesome.
Okay, give me 2-3 minutes at max because I want to close and finish one easy thing about is for the demo.
Okay, I guess we can do that then.
Come on. Yeah. Where is it?
Cool. Okay, I guess yeah.
Okay. Chart. Where is it?
Cool. So we will have our next speaker, as you have heard, like in a few minutes. Yeah, that's pretty much it. So like I was saying at the beginning, but I don't know if you guys heard, because of the sound issues at the beginning. But yeah, the conference very likely is going to happen at least once a month, depending of how successful this edition is. And yeah, so the idea is like instead of doing like a 2-day conference that would be like physical, is to kind of like shift that perception and just making it shorter. So it's going to be like few talks, so around half a day, so people can watch it like if they're in Europe, like in the evening or late afternoon, and if people are in California, they can still watch it in the morning. And this is the best way to cover like multiple time zones. And instead of having something like which is like too long and takes too much time, we just have like half a day together. If there is any topic you would like to see in the next edition, don't hesitate to make a suggestion in the chat. And the call for paper, I think, is probably going to be the same link anyway, so feel free to apply for it. And yeah, then your talk may also get selected for the next edition. So I guess we are almost ready for the next talk. And let me unmute. Yeah. Can you hear me now?
Hi. Yes.
Cool. Okay. Let me just move your screen. Tack.
Yeah. Can you see the presentation?
Yeah. No, we should be able to see it. Yeah.
Okay.
Yeah. All good. Yeah. You can start whenever you're ready.
Okay. Perfect. So this afternoon or good morning, depending where are you. So I'm going to talk about a project I've been writing since last year. The talk is about how to recover as much as possible source code that we can compile by just clicking a button or running some script. So I will first talk about what is the problem that I wanted to work, what is the idea that I did and what I'm working right now, the prototype that I have, that I will have to drop and rewrite again because it is a prototype, and then talk about the future of this idea and about the tool that I want to write. So first of all, the problem. Often for so many reverse engineering tasks, we need to extract pieces of codes from binaries to copy in our source codes. It can be either simply global tables or something like that, for example, for encrypting algorithms, or it can be wall algorithms, or it can be even many functions at the same time that we want to extract and put in our project for whatever reason. Some reasons that come to mind are, for example, compatibility, copying decryption routines from malwares, which is pretty common, doing recovery or reconstruction of lost source codes, or half automating porting of codes written in assembler to high-level languages. I know, for example, groups, the people that are trying to rewrite in higher level language, like in C, C++, old games that were written purely in assembler using Ghidra the compiler. Well, such a tool could help these guys. So, for example, talking about compatibility in this case, what I mean is, let's say that we want or that we need to be compatible with some commercial software that is only available in binary form. So we do reverse engineering of that obscure algorithm that the software is using for that specific or rare file format that they invented. So what we can do is, after we reverse engineer it, we can either implement everything from zero by writing specifications from the reverse engineered piece of software, and then from the specifications write code. This is commonly done, or we can directly use portions of that commercial software directly into our software. Yeah, it doesn't sound very legal, but I'm ignoring legality here because legality is depending of the country where you are. And when we are talking about compatibility, it is even more fuzzy than it usually is. So I'm just ignoring it. And also because regardless of legality, it is business as usual in many areas. For example, antiviruses or commercial game cheats do it all day. So, for example, one of the samples that I said, copying decryption routines, is very common in the anti-malware industry to just copy even verbatim algorithms from malwares, for example, from a file infector, after reverse engineering them. Indeed, I have done this myself when I used to work for one antivirus more than once. So manually rewrite from assembler to C some routines that this some disinfection or whatever, and then write AV plugins with these functions that I wrote directly from assembler to C after cleaning this or that for some specific file infector. Like, I don't know, in my case, it was Sality back in the day. And I know people that have even directly copied raw assembler and put it in ASM blocks in their C, C++ files. Please don't do that ever. And if we are talking about legality again, well, I don't think that in this case, for example, malware authors are going to complain about their intellectual property being used anywhere, I guess. This is the top idea, or why I really wanted to write such a project, which is recovering or reconstructing lost source code. This is one of the top 10 most common reverse engineering tasks, I will say. And also, I believe that it is one of the top 5 most tedious reverse engineering tasks. So one example, let's say that we have some company that produce some specific software for some specific industry. Due to a disaster, that company loses all or part of the source codes for that specific software. So that company contracts reverse engineering services, so the reverse engineers can reconstruct from the binaries they distribute to customers the source code. This is more common than what you might believe, and you might think about it only happening to small companies, but it happens to all companies all around the world. It might happen to big companies and to small companies. I have histories about both of them. Well, with a bit of luck, in that case, for the reversers, they might be lucky enough to have some version with divine symbols, with like, I don't know, dwarf or PDB files, so they have more information. But in most cases, you will have just raw binaries distributed to the customers. And it can be even worse. It can be even with some software protection measures, so you have to first crack the software. In this case, I'm totally ignoring also this example where the reverse engineers first have to crack the software. We consider that the tool that I'm going to talk about is when you already have reverse engineered your software and you want to start reconstructing the source code out of it. Okay, so there are other examples that I could talk about that for which we will need to extract some pieces of code from binaries to copy in our source code, but I think these are some good examples. So right now, the only part of the solution to this problem and what we all do is the following. We reverse engineer the software, whatever is our target, then we discover structs, enums, function names, etc., etc., and then we copy and paste directly from IDA or Kira to our source code. We adapt the code and clean a lot of the stuff, and we make it compilable for our specific project. Well, it can be done this way for small parts or for when we are copying, say, a couple of functions, something like that. But for big codes, let's say that we are recovering a full, I don't know, management application. That's not going to work. It's not feasible. Cannot start copying this function in this function in this another file for, say, maybe 1,000 files difference that we shall have for compiling back to that management application. That's not practical. So this is my idea. The solution to the previous problem is obvious. I say it's obvious, not easy. So we just need to write a tool that automates most of the tedious and boring routine tasks. We should make it interactive because this is my experience, but most of the tools that I have been written for reverse engineering, when they are interactive, the reverse engineer can interact with them. They are better than purely batch tools. So in this case, we need interactivity to fix whatever the tool, whatever mistake the tool makes or whatever wrong guess it makes, because we are not going to write a software that makes better guesses than a human. And we actually need the human to verify that whatever the tool did was correct or not. Also, we want to allow incremental changes, even when such a software, in my mind at least, is meant to be used when you are mostly done reverse engineering your software. You want to fix the stuff incrementally. Let's say that we have some function names and some variable names, but then after we are working with that, we realize that one of the function names that we assigned was wrong. We just want to change that function name in that specific source code file it belongs to. We don't want to rewrite the whole project again. Also, we want such a tool to be integrated with the de facto reverse engineering tools, which are IDA and Ghidra right now. And, well, maybe after that, profit from the tool. So, yeah, it sounds easier than it really is, but it isn't either that hard, in my opinion. Actually, I don't really consider it a pure reverse engineering problem, but more of a software engineering problem, because we are not, for example, searching for classes and their hierarchies in binaries, which is actually a pure reverse engineering task. We are just going to output compilable source codes using the compilers, using hints from and interacting with the reverse engineer. Roughly, this is all we are going to do. So this is always in my opinion, okay? So what such a tool should do in my opinion? First, find functions and the correct prototypes. Probably the reverse engineer wants to fix them. Find local and global variables. Probably the reverse engineers want to fix the types or the names, etc., etc. Finds import functions and the corresponding header and library files. Like say, if we say that our target is used calling fopen, fclose, whatever, or I don't know, cout, we know that we have to do import stdio or import iostream, etc., etc. Also, we need to find the source files in the binaries. I don't want to have a huge C or C++ file with, say, 10,000 functions. No, I want to recover from the binaries something that is as closer as possible to the original source. How do you do that? You need to find what looks like where the original source files, and then split the functions in the single binary we are working on to the specific source files it belongs to. Last but not least, we need to find the hierarchy of structs, enums, functions, globals, etc., and just write the source code files. Yeah, it sounds more easier than what it really is. So some disclaimers before I start. First, I'm only talking about C programs, just plain C programs. I'm not talking about recovering something like Visual Basic, Go, Delphi, you name it. I'm just talking about C programs. Also, during this talk, I will only consider the tools IDA and Ghidra. And the reason is that, well, these are the only two reverse engineering tools that they have on the compiler of their own. That said, let's continue. So, I repeat again, let's assume that we are just talking about C programs. The first thing that we have to do is finding functions. It is easy, okay? We can just use the APIs of IDA and Ghidra. We might need to manually find and create some functions that IDA or Ghidra didn't find. This is especially true when talking about reverse engineering embedded devices, where most of the functions aren't ever usually, better said, discovered by IDA or Ghidra, and we have to write our own scripts to find some more functions. And also, finding functions is not a very easy problem because distinguishing between data and code is not trivial. Anyway, nowadays, most tools, or these two tools, IDA and Ghidra, work pretty well in most of the cases. Also, we need to fix the function prototypes, which is one of the areas where the compilers really fail a lot. So many times, the calling conventions, the number of arguments, the types especially, are wrongly guessed by the compilers. That's normal. I understand it. It's not an easy job, and it's not something that can be, in some cases, it's not something that can be statically determined. But it is fine. As long as such a tool for recovering source code is interactive, we can just interact with the reverser, and the reverser can just simply change the function prototype in either IDA or Ghidra, and that's it. Yeah. So there are many cases, however, where functions can be missed or the boundaries wrongly guessed. Some examples are virtual functions, jump tables, many different switch idioms, self-modifying codes, on-the-fly generated code, function tables exported by external libraries, etc., etc., etc. So we cannot write a tool that works in all of these cases. It is pretty much impossible, but we can focus on a tool that might work in the general case, and maybe, if it makes sense, tomorrow enhance or improve it later. So, another part, finding local and global variable. So this might sound easy too, but it isn't either. So variables are in a concept that exists, as far as I know, in most CPUs. So we don't have a concept of variables in Intel 86 or in AMD 64 or in ARM 32. They are just memory areas. We need to apply data flow analysis to find them and to find the alias. For example, in a white paper written by Ilfai Kilfanov called The Compilers and Beyonds, there is a specific part talking about this, how to discover variables, which is called variable allocations. And in Ilfai's words, he says that only that part is worth a separate paper. This is the specific part which Ilfai Kilfanov says so about local variable allocation. Fortunately, however, in many cases, for most of multiple targets, finding local variables isn't that hard, and that's not our job in most cases anyway, because it is the job of IDA, Ghidra. We just really need to fix things like assign proper types, map some variables that might be duplicated if we feel like doing so, etc., etc. Finding global variables, however, is usually more easier. We just quoting just needs to find references to memory addresses outside of the segment where the code is. This is one of the ways to search for global variables. or read-write memory references to outside of the current function's boundaries, because maybe we are uh, targeting or reverse engineering a software that mixes data and code in the same segments. It's not very common, but it might happen. Uh, Also, distinguishing between constants and variables might be done by checking the permissions of the segment. For example, if it is read-only. In most cases, we don't really care. We can post a variable declaration with assigning some specific constant value, like, I don't know, const star char, some name equal and quoted some string. And the compiler, when we are going to compile, is going to remove that variable and just put the constant in the raw data segment or wherever it is relevant, depending on the compiler. So in opposite to the previous case, this is, however, our task to determine if we are dealing with a constant or a global variable to output compilable source code. I think it is more readable when we are recovering source code to, for example, let's say that we are talking about a printf code, issuing or writing printf and quotes the whole constant than doing printf, some global variable, and declaring the global variable somewhere. So you have to go to that somewhere part and then check the global variable. I will talk a bit later on about how I have done that in my current prototype, but well, we don't really care about it. Okay, so finding external functions. There is another thing that we need to do is to find the external libraries being used and the runtime functions used by your target. For example, let's say that we are reverse engineering some piece of software that is using the functions create file A and the function sqrt. So depending on these functions, we will need to add the proper header files as well as the corresponding library files to link with. For example, if it is using create file I, we want to output source code files, including the Windows.8 header file. If it is using sqrt, we need to include the mat.8 header, and we also save somewhere that we need to link the mat library into our project. We can actually do it in an easy way. With easy, I mean, what I have done myself was parse the whole /user/include of my home Linux box and parse all the header files that I have in my Ubuntu box at home with clang and extract or generate some huge tables that I have in my prototype that says that function is used or requires that header file and that library file to be linked with. It must sound a bit complex, but it really isn't. It is the easiest part, I believe, of that project. So as I said, header files must be added to the specific source code files we are going to write that are using them. I mean, we don't want, if we know that in some specific file, like, I don't know, main.c, they are using create file A, we want to include Windows.8 in that main.c or cplp source file, but we don't want to include the same header again and again in other parts, in other source files that they aren't using that function or that header file. Okay. More. So finding source files in the binaries. Just this task by itself, I believe, is a well-researched topic. So it can be summarized or can be explained in another way. So how can we guess the object files boundaries and thus the source files boundaries in binaries? Actually, I know one guy that have done some research in this specific area. His Twitter handle is EVM_sec. And he has done at least in Recon, and I don't remember where else, probably in SummerCon, but I don't remember properly, a talk about doing so, which is called a Code Pirates Catlash, Recovering Software Architecture from Embedded Binaries. So basically, what they do is, when you are linking your project, you first compile your, like in the picture shown here, you first compile main.c to main.o, then matlib.c to matlib.o, etc., etc. And then when you are linking, usually in the order that you put the object files to the linker is how they are going to be in the final binary. They are usually in that same order. And doing magic that this guy is doing, it infers what are the boundaries of the original object files that were used to link together for your final target. So if we have debugging information, we can skip this step. But if we don't have debugging information to determine which function belongs to which object file or source file, we will need to do something like this to determine which source files are in our project and which functions or globals or whatever belong to which specific source file. Okay? More. So finding runtime functions. We also need to find the users of C or C++ runtime functions, but basically to ignore all of them. We don't want to add, for example, libc, start main, or gmon start functions to our generated source code files, because this is something that the compiler, in this case GCC, adds. Sorry, and we don't want to recover the runtime parts. So the solution to this problem is kind of easy. For example, using IDA, we can use the flirt signatures, and whatever was recognized by the flirt signatures, just ignore. Also, if we have function names, we can also blacklist some of them. But this is a never-ending history because you have to blacklist a lot of functions from a lot of different runtime, from a lot of different compilers. Also, we must let the reverser somehow specify which functions must be skipped or must not. Probably we don't want to use, we don't want to export some runtime functions, but maybe in some specific case, we need to export them. I cannot figure out right now why, but it can be required for some reason. More, finding object hierarchy. So let's say that we have reverse engineered a target for some time, and we have proper function names, local variables, globals, structs, and enums. Now, when writing source code files, we need to know which structs, functions, enums, global variables, etc., are used by each source code. Also, source file, if you prefer. Also, we need to remember that structs, functions, etc., etc., might depend on other structs, types, functions, etc., etc. Let's say that we have some struct A with two fields in something, and then we have a struct B with int with a field int something, and the second field is a struct A field name. We need to have the hierarchy properly to write the struct in the proper order, because otherwise we will have compilation problems. It is pretty much impossible, in my opinion, for big enough projects to write a magical tool that you click in a button and you have full compilable source code. However, you can make it as much easier to get compilable source as possible. And for doing so, this is one of the basic tasks that must be done. We could work around that by adding a lot of external declarations and adding ifdef macros, but this is ugly and it's pretty much unreadable, and macros cause a lot of problems. I don't recommend doing anything like that. This is just my opinion. And well, finally, the last step is to just write the generated source code files with all the required dependencies and with the whole hierarchy result, plus the building files. With building files, what I mean is how to build the source code that we just write. In my prototype, for now, I'm just generating plain make files, but we could generate anything. We could generate building files for CMake, Visual Studio project files, for Ninja, or for whatever else that we might want. Okay, the prototype. So since September last year, I have been working on a prototype for now of such a tool. The prototype is an IDA plugin plus IDA Python tool. I call it Source Recoverer. I'm not very original, I guess. Let's briefly discuss about it. So first, the components of the prototype. It is an IDA C++ plugin that I call IDA Unexposed, which is to simply export one function that I need, because the function's prime type and format data to get a compilable representation of global variables, constants, and stuff is not export and cannot be used from IDA Python. So I just export a function called getCdef from a C++ plugin to do so. And then an IDA Python independent script that uses the previously mentioned plugin and does everything expected from a source code recovery tool. Everything that I have been discussing about during this presentation. So how it works? As I said before, it iterates all functions in the binary. It guesses all the source files if possible. I use the backend information when it is available, which is not by default, or otherwise I use another IDA Python script that I wrote some time ago, IDA Magic Strings, that tries to determine which functions belong to which source code source files. So this is one of the ways that I'm using in my prototype to try to say this function belongs to main.c. That other function belongs to, I don't know, misc.c, etc. And so I get all the structs, nums, and global variables using IDA for now. Then I decompile all the functions. I write a project file so the reverser can make changes about how the code is being written. And then source code with the dependencies that requires mostly full resolve are written, and a makefile for building the code. Also, when something is changes in IDA, only the modified part or source is modified. For example, let's say that we have some function where we have some specific variable name, which is an automatic name like v1, v2, v3, and we want to change to something. Like if we change v1 to option, when we are going to write again source files, we don't want to write the whole project. We just want to write the specific source file where that function that we have changed has changed. This is what it does. And that's it, basically. Let's see some demo. Give me a second, please, because I have to share now my wall screen, and I am still very new to Zoom. Give me a second, please. Just a second. Yeah, desktop sounds great. Okay, so this is my desktop. And let's open now one binary. Okay, so the binary I have opened right now is called CMD scan. It is actually the command line scanner of one antivirus, of Komodo antivirus. It is a very easy to reverse engineer piece of software, and I have many things already reversed here, but I haven't changed too many things. Okay, so what I'm going to do now is to just execute my script, which is that, recover, and see what happens. Okay, it has done everything it needed to do. It has treated first the project file, which is that one, CMD scan. This is the IDA's database name dot recover. We can open it here. Here's it. And well, this is a project file with many things. We will take a look to it later. And it says that it has written the following files in this directory. So we are going to go to that directory. As we can see here, we have the CPP file with all the functions, an auto-generated header file. This file, devs.h header file, is something it created, and then we have the make file that it creates. So this is the first time that we just execute my prototype over this piece of software. It's all failed the first time. Make. Okay. Recipe for target, whatever, it fails. Let's see why. Okay. So in the auto-generated header, it says that we have redefined one struct. Okay. The tool is failing because it's failing to build because we have some redefinition of a struct. Let's fix it in the header file. Okay, yeah. So we want to remove this ones, and we only want to have this specific struct that I have reverse engineered. Save, that's it. And the next part is, it also complains here because the gmon start was not declared. Of course, because this is something specific of GCC and specific of the runtime, we shall not be doing anything with gmon start. So I'm going to check in which function it happened. 78, it says. Let's go to it. Sorry. Yep. 78. And the function is that one. Let's go now to IDA. Here we are. So we don't want to export that function. How can we do that? We open the project file, and we have a section which is called ignored functions. We are just going to add one more ignored function. Okay, and run again. This is incremental, okay? Now we see that it is ignoring that function. It only wrote one source file. Well, actually, the only one that we have for that project, but if we had more, it will only output one, and then we can go again here. Let's do make. Sound file now. Yeah, okay. There is one more function that is failing. Sub, some address. Let's go here. Okay, this function is a thank function. By default, in my prototype, I ignore thank functions. However, as I said, we need interactivity, but because even when in most cases we don't want to export thank functions because they are automatically generated, maybe in some specific cases we won't. And actually, in this case, we want to do so. So what we do is in force as, there is a section called force as in the project file. We just add the function that we want to force to be added. Again, it is incremental, so we go here, we run again. Now we should have that function here somewhere. It is here. The only thing that I haven't done is to put the reference here in the header file, because the header file is only written once, unless we specify otherwise. Build auto-generated header. By default, it is only written the first time. And now let's go back again. We dump again the source. And then if everything goes OK, now we have working source code that we can compile, and the binary is working. It will not do anything because I don't have here the libraries that Commodore requires, but we just wrote a certain source. We just decompiled literally and generate this compilable source code from a binary without too much effort, I guess. 1 second, because I'm going to start again the presentation. Okay. Yes. So the future of this tool. So the current tool is just a quick prototype. All the steps that you have seen I have done myself. Now, for this specific project, solve be done automatically. By now, the quick prototype I have written works, but it sucks hard. It really needs to be rewritten properly. I will most likely rewrite it in C or C++, but well, that's just a matter of taste, nothing else. Supporting Ghidra was considered, but the compiler generates too many constructions that are incompilable and they must be cleaned. So for now, I will focus exclusively on IDA. Also, it really needs an integrated, reverse-friendly GUI. Right now, we have to manually update the project file, which is a JSON file, but we need a proper GUI to assign functions to source files, select which local types we want to export, which ones we want to ignore, which functions we want to add or to ignore, whatever. Actually, two of the steps that I have done here by modifying and writing stuff in the JSON file, so will be done by just clicking somewhere. In the current version, source files are found using one of the following two methods, either using debugging information, dwarf mainly because with PDBs it doesn't properly work for a reason, or using debugging strings containing file paths, like, I don't know, something like assert error in file all the path.c. This is how I try to guess where one function belongs to which source files. In the next version, I plan to implement my own version of the EVNSX algorithm for local function affinity, as he calls it, to try to infer translation units, source files, if you want, boundaries in binary files. And also, this part is anything but easy, is classes recovery. This is a whole project by itself. The idea is to try to find the classes being used in our target, resolve the hierarchy, and finally write the definition of the classes too. It is not trivial, but that will be awesome to have in such a tool, I think. So the prototype will be released at some point this year. I cannot release it right now because I have to clear some problems with my employer regarding the tool. And the final tool, the final, not the prototype, hopefully will be available by the end of this year. But I cannot be sure, and considering that we are living a pandemic, who knows? And well, that's all. If you have any question.
Yeah, thanks for your presentation. So yeah, chat, if you have any question, you can ask them now. But while we're waiting for some questions, I have two questions for you. So the first one is, you say you look at Ghidra and then you kind of quickly gave up. Is it because like the quality of the decompiler is that far behind compared to IDA? Or?
Yeah, well, that's only my opinion, okay?
Because I haven't tried it, that's why I'm curious to know about it.
Yeah, that's only my opinion, okay? But I have find many cases, for example, where some constructions aren't properly decompiled, or they are properly decompiled for reading, but not for recompiling again. I mean, some constructions, you can read them, but you cannot feed them to a compiler and expect it to compile them. No, not at all. However, with Hexrise compiler, I have noticed that they can do so. This is why I'm ignoring for now Ghidra. But, well, the quality of the compiler is pretty good, but I don't think it is as good as the quality of the Hexrise compiler. On the other hand, anything that you can disassemble in Ghidra, you can decompile, which is something that you cannot do with Hexrise. So.
And does it support more platform on Ghidra? Do they have like ARM64 decompiler, or is it only like x86, x64?
So in Ghidra, whatever you can disassemble, you can decompile.
Okay.
That's it. Whatever you can disassemble. It forces you to write a processor specification that is later on translated to P code, and based on that P code is how the compiler works. In the case of Hexrise, it is not like that. You have to write a specific compiler for a specific processor.
I see. And so there's a question from Ryan. thanks for your presentation and work. Will you post the slides publicly?
Yeah, of course. The slides will be public. Like I don't know. Give me 5 seconds after the presentation.
Yeah. Like most of all the slides from today are gonna be on our GitHub repository anyway. After we're gonna centralize everything over there, like we do for each edition of our conference. So that's good. And my second question was, so your example now was on Linux. Did you try on Windows with but for binary with private symbols with a private PDB to see if you get like some really good results with it? Or because I guess one of the big problems is also like type discovery and type recovery, right?
So yes, I have done, and yes, it works. The thing is that it was easier for me to do the demo in Ubuntu, but yeah, I have done that.
Okay, that's pretty cool. That's awesome. And what about public versus private symbols on Windows? Do you see like a massive difference or not that much?
Yes, there is a massive difference.
That's pretty cool. Nice.
If you have private symbols, it is going to be much easier to recover source code. If you have public symbols, good. It is good to have that information, but still you are going to have to fix many things. The less information that you have, the more work that you have to do manually.
Yeah, because I'm thinking like for like private symbols, and few times on Windows, you know, those symbols have been leaked publicly. So, and what about, is it only for like user mode application, or you can also do it for like kernel drivers? Or
that. I mean,
that's cool.
It doesn't matter. I mean, the two-line rating, it will just output source code. It will write a makefile, supposing it is going to be used in a user-land application, but it doesn't really care about what is the target that you are reverse engineering. It can be a kernel, it can be a kernel module, it can be whatever.
That's pretty cool. Yeah, like Jaziel Spellman in the chat is saying looking forward to the release. Yeah, me too. Well, at least the good thing about the confinement is it gets more like time. You should get more time to focus and to write those tools. You know, usually like it's kind of hard to focus, especially writing such a big tool. On your own, it takes a lot of time. But yeah, I think it's gonna be like really cool.
It takes a lot of time. Yeah. So my current prototype, I started writing it by September last year. It works, but it still sucks. So I will need a lot of time to finish it.
Yeah. But that's pretty cool. Well, thanks for choosing Opcode for like the preview of that new tool. That's really awesome.
Thanks to you.
Cool. Well, I don't think we have more questions in the chat. I don't see any other questions. Is there anything you want to add?
Nothing on my side.
Okay, cool. I guess we're gonna get ready for our next presentation, which is gonna be on my Catnip. I'm pouncing over APTs for the purple teaming from Katie, Jesse, and Andrei from Microsoft. Thanks, Joxean. How do you pronounce your name, by the way? Is it Joxean or Joxean?
Joxean or Joxean.
Joxean.
Joxean, yeah.
Okay. I know it for next time. Okay, well, thank you, Joxean, and hope to see you soon. And,
thanks to you. Bye-bye.
Bye.
Social distancing, you say? The future is watching. Welcome to OpCode Virtual Summit.
And I guess we are back. So now let me get ready for our next speakers. To be honest, Zoom is kind of making it a bit confusing to find the windows. I'm trying to find that one. So I hope everything is going well so far. I see some people, the real lesson is learning how to pronounce Matala's name. Joxean, so we'll remember that properly. But yeah, like I see we've around like 100 people watching the stream. It's pretty good surprise for a first stream. I didn't really expect to have more than 10 people, to be honest. So it's thanks for watching. And I see we have a bit of people from everywhere. We have some people from Kenya watching here, or the team from SheHacks and Africa Hackon. Thanks for your support. That's pretty cool. And no, I lost that window. Exit, minimize view, Andrei unmute, Katie unmute, and Jesse unmute. Can you hear me, Andrei?
Yeah, we can.
Oh, okay, perfect. Yeah, it took me a while to find the unmute button, but we're back online now. Cool. So Jesse, Katie, and Andrei are from Microsoft. They're gonna talk about, I guess it's a Purple team talk. And yeah, are you guys ready to start?
Yep.
Yeah.
Great.
Awesome. You can start sharing your screen, and I will put you on the stream.
Sounds good.
And I guess we're good into full screen mode.
Can you see my screen?
I think yes, you're on the screen.
Perfect.
Awesome.
Can you hear me?
Yeah, perfect. Yeah.
Okay. Welcome everyone. Today we'll have a cat-themed discussion about APT emulation. So for starters, quick disclaimer, if you do have ailurophobia, we do want to let you know that we will have cats in this presentation. And also, please don't use any ideas, code, or cats presented here for malicious purposes. So starting off with some quick intros, I'll start us off. I'm Katie Chuzie, a software engineer on the red team at Microsoft.
I'll go next. My name is Jesse Zhang. I'm also a software engineer on the red team here at Microsoft.
Quick note, guys. I think I don't know what's the resolution of your screen, but apparently it's like a pretty big screen because I only have part of it.
Okay.
Yeah, in the share screen, like fit original. I mean, let me try. Okay.
Is it like that for anyone else?
Yeah, I guess it's okay now.
Okay.
Just like it sounds like you have a massive resolution, though. Huh? It's like but all good now. You can carry on,
Okay,
guys.
great.
Thanks.
Andrei, did you give your intro?
Andrei might be on mute.
Oh, okay. Give him a second.
So it looks like Andrei's having some problems unmuting himself. Matt, can you mute him again, please?
Who is unmute, you say?
Andrei?
I think Andrei.
Oh. Check, I don't think so. Oh, yeah.
Hi, can you hear me now?
Yeah. Sorry for that.
Perfect, nice. Yeah, so I'm Andrei on the red team as well with Microsoft. Thanks.
Perfect. All right, cool. So why are you all here and what are we here to talk about? So we will be showing a lot of cats throughout this presentation, as mentioned. We'll introduce the concept of purple teaming and how we practice it at Microsoft. We'll also talk briefly about how typical command and control infrastructure works and talk specifically about the C2 infrastructure that we've implemented. We'll also do a deep dive into the APT research that we've done and how we've implemented many TTPs to achieve APT emulation. And lastly, yeah, we'll just talk specifically about the different TTPs that we have implemented. So to start off, let's talk about purple teaming. So what is purple teaming? I'll let you all read the formal definition, but basically it's a methodology where the two sides, red and blue, come together and share knowledge with the ultimate goal of making each other better. And for those who aren't familiar, which I'm sure most of you are, with the concept of red versus blue, obviously the red team is impersonating the real attackers and actively trying to break into systems, whereas the blue team is monitoring the attacker activity and trying to detect and evict them from environments. So how does a typical purple teaming exercise work, and how do we do it at Microsoft? So typically, the red team is issuing attacks against test environments that are stood up specifically for this exercise. And their goal is really to see how they're getting detected, what attacks are being caught, and then use that knowledge to improve their evasion tactics. Whereas the blue team, on the other hand, is monitoring red team attacks and looking for any alerts that may fire. And this allows them to see gaps in their detections and ultimately make improvements. So moving on to our solution. What does purple teaming really have to do with APT emulation? Why are we bringing this up? Ultimately, we wanted to improve this process. We wanted to improve our exercises and make them more efficient. We wanted the blue team to really be able to not just detect red team actions, but detect real APT actions as well. So this drove us to create a tool, which we've named Copycat, to try and achieve this goal. It has a built-in C2 infrastructure. We've also done in-depth APT research, which has helped us to implement many APT tactics, techniques, and procedures in order to achieve APT emulation. And lastly, we've also implemented a lot of custom modules to assist our APT campaigns. So pivoting off of purple teaming, we'll now start to talk about our C2 infrastructure that we've implemented. And you may also be wondering, what does a C2 have to do with this? How does a C2 help us achieve this goal? Well, first off, we're already using C2s in our engagements, so we're familiar with them and we know how they work. Secondly, they make it really easy to deploy binaries for the different APT groups that we support. And lastly, a C2 allows us to easily run specific commands that are required for a specific APT profile. And I'll hand it off to Jesse to talk about our C2.
Thank you, Katie. And so now let's talk about our C2. In this instance, it stands for both command and control as well as copycat. Next slide, please. First off, let's discuss the high-level infrastructure overview here. On the left-hand side, we have an attacker who's sitting in front of his or her machine, which is noted by that red stack of machines right there. For this talk, we will call that the C2 server. And then from there, the attacker has to have some way to really attack the victim, right? I mean, if you don't have a victim's attack, what's the point of having C2 server set up? And with most of these C2 frameworks, what ends up happening is the attacker will send off some sort of malicious link, some sort of malicious attachment or email that points to something malicious to the victim, and then eventually the victim does something with that, right? Within our infrastructure here, that is denoted by the first line on the left-hand side. You see that we have the email icon, the paperclip icon, as well as a cloud icon. That really denotes a couple ways that the attacker can send that off. With most C2 infrastructures and C2 frameworks, a lot of times what they call this is like the dropper. Then the dropper drops a payload onto like the victim's machine. Sometimes within this step, you also see certain items, especially people who are familiar with Metasploit, that occasionally has like stagers and things like that. We don't have stagers in Copycat itself, at least not on the basic level. We kept it pretty simple for that. But we do have a dropper to deliver the backdoor. Now, once the victim unknowingly clicks on the malicious link or opens up that malicious attachment, the program runs on the victim's machine. And at this point in time, if you look over to the right-hand side, you see that our attacker is now sitting on top of the victim's machine. At this point in time, the machine is compromised. And for this talk, we'll call compromised machine a zombie, but other frameworks might reference this as an implant. Sometimes they may call it a bot, some other things. There are all these different terms out there, but we'll call it a zombie for now. Now, once this machine becomes a zombie, it has to establish some sort of communication channel. And for Copycat, what we've done is utilize the reverse TCP. So if you look at the middle cat tracks there, the top cat track is the zombie reaching back out to our C2 server, and the bottom cat track is the C2 server communicating back to the zombie itself. Now, it is called reverse TCP because it's the zombie communicating first to the attacker's machine, and then the two-way communication channel then gets established and they communicate with each other. And then at that point in time, we can utilize the C2 server to send commands, run our APT campaigns, or drop or upload or download data from the zombie machine. A couple things to note, of course, is that this is just one example of a C2 framework, and in particular, what we've implemented for Copycat. Of course, reverse TCP protocol, there are a lot of other ways that the attacker machine can communicate with the zombies. Either you have direct TCP. You could also not even utilize a TCP framework. You use UDP, ICMP, and whatever other protocols you can get communication channels going from there. Next slide. So we've looked at the infrastructure in our last slide, and now we're going to talk a little bit about our tech stack. And keeping with our idea of simplicity and making this easy to implement, we've utilized only Golang with our entire tech stack. And the main reasons for this is, first off, it runs almost everywhere. We write our Golang code, and we can then compile it or cross-compile it to almost any framework or language, excuse me. So this includes the ability to allow it to run on Raspberry Pis, which has proven to be very fruitful, especially if you want to drop Raspberry Pis in random areas. I don't know, for instance, in conference rooms, or plug in random ports, plug it in, and then you have your copycat running, and it reaches back out, which is very, very useful for us. And the second reason why we utilize Golang is because it's simple-ish. The reason why I say that is if you have a little bit of experience with some coding languages, and even if you don't, it's fairly easy to pick up quickly and get working code going. And finally, the third reason why we love Golang is because it's fast. Now, if you looked at our talk description, we did promise that we're going to teach you how to build your own C2, and this is our recipe for copycat. Now, with any good recipe, we have our list of ingredients on the left-hand side, and we have our directions on the right-hand side. For the ingredients, we have three main ingredients. First, you need a TCP listener. Second, you need an infinite loop to accept all the incoming connections. And the third item is, for every connection that does come in, you need to have a handler that can actually handle that client's Zombie or endpoint. Now, in terms of directions, first we want to read the command from standard in or WSS on our C2 server side. Then we want to bake the command a little bit, give it a little bit of love. And what we really mean by that is we want to see if the command is going to be run on a Windows Zombie or Linux Zombie or whatever other OS is out there. Now, if it's being run on Windows Zombie, we want to run the command through cmd.exe. But if it's being run on Linux, then just run it through whatever bash or whatever shell is being running at that time. Now, we also want to check to see if the command is an internal command to copycat itself. Of course, if the command is not or is internal copycat, if we were to send that off to our zombie had no idea what to do with it. It would try to run on the victim machine and say, I have no idea what you're doing. This doesn't work, probably throw an error or something like that. So we do want to make sure we check the command to see if it's internal to the copycat. If it is, runs it on the copycat side. If it's not, then send it off to the victim. Finally, we do send the command to the zombie itself, and then we read the incoming data from our zombie. Now we're going to dive a little bit deeper into the ingredients and code snippets. We all love code snippets. So as we listed before, in terms of our ingredients, we have our TCP listener, we have our infinite loop, and we have our zombie wrangler, which is what we're going to start calling each thread that handles the incoming items. So on the on the right-hand side, the first code snippet is our TCP listener. And what we're doing is we're utilizing Golang's net package to do this. So we're using net.listen to open up the TCP port to start listening. And then afterwards, we want that infinite loop to be running to be constantly open to make sure that as there's zombie connections are coming in, we are accepting those. And so we have our for loop in our second code snippet that's just running a server.accept and just constantly running, just waiting for those zombies to come in. And then finally, we have our zombie wrangler itself. And going back to our previous point about Golang being simplish as well as quick, you'll see that towards the bottom, we have something called a Go space handle client. And that Go keyword right there is utilizes what's called Go routine. And this essentially allows our code to be multi-threaded, and it creates threads as items are coming in. So it will create a thread for every handle client, a class, to be able to manage each zombie that does come in. So as you can see, that makes our life a lot easier. Golang just gives it to us with a single keyword right there. But those are our three ingredients right there. And then we'll dive a little bit deeper into our directions. I won't go through the directions verbatim again on the left-hand side, but if you look at our code snippets on the right-hand side. So the top part is us processing the command. So it's reading the command from standard in or WSS, and okay, what is this command? Next up, we're doing the baking it a little bit. So you see that it says, is OS Windows? Let's check if it's a Windows operating system. If it is, let's run it through cmd.exe. And then afterwards, we do a little bit of encoding of the message, and then we send off the message to our zombie. And afterwards, we read the incoming data from the zombie, and then we display it back to the C2 server user. Now, next up, Katie's gonna talk a little bit more about our APT research. Katie, you're on mute.
Good call. Okay, cool. Thanks, Jesse. So starting off, we're going to talk a little bit about how we find the campaigns that we're going to implement. So we use a variety of different resources, both internally as well as externally to Microsoft. We start off doing a little bit of research on the APT to understand just at a high level the different TTPs that are used. So we do this by gathering knowledge online from, for example, Twitter or different blogs or RSS feeds. And we also consult with our internal threat intel team as well as our SOC to kind of get a good idea about which APTs may be top of mind. Then once we have that foundational knowledge, we then go looking for actual samples and reports that will give us specific IOCs that we can implement. We gather this data from a variety of online resources, including those listed here. And it's important to note some of these are free and you can look at the samples and reports with free of charge, but some do cost money to sign up. There we go. Wasn't wanting to advance. Okay, cool. So once we identify our samples and reports, we then need to figure out exactly what IOCs we want to emulate. So we do this in a variety of ways. We've developed some automation into our tool that does automatic IOC extraction from various feeds and blogs, looking for things specifically like file names and registry keys. And then we also do a bit of manual analysis in addition to automation to extract those IOCs. We look through the reports and code and try to identify things like file names, registry keys, domain names, etc. And lastly, we take the actual code samples that the real APTs used and do a bit of reverse engineering. But of course, we do strip out the malicious parts and try to replace them with something benign, perhaps popping calc instead of the malicious binary, while still retaining the same functionality. So now we've identified our IOCs that we want to emulate. So now we have to implement this into Copycat. So this diagram gives you a high-level view of what this looks like inside of the tool. So basically, we have our threat actor, which can have profiles. And the profiles are, of course, unique to each threat actor or APT group. So those are represented by the fingerprints. Then for each of the profiles, you can have one or more campaigns. And these campaigns consist of 3 different things. So first, we have a command file, which lists all the commands that will take place on the victim machine when the campaign is executed. We also have any tools included in the campaign that are used to assist the campaign on the victim machine. And then lastly, we have a README file, which basically just gives an overview of the APT group itself, as well as the different actions that will take place within the campaign. So now we'll move into specific examples of the different profiles as well as campaigns that we've implemented inside of Copycat. So starting off, this first campaign is from the APT group Turla Dark Neuron. This started out as a spear phishing campaign targeted at the Saudi Arabia government. And we've emulated here their initial entry, which was sending a phishing email with a Word document attached containing a malicious macro. So we have implemented the malicious macro as well as other specific IOCs. So here, one example of a specific IOC is the APT's use of certutil to decode and then execute the malicious executable. And then here we have the base64 encoded payload that is decoded and then executed. So for this example, this chunk of code actually triggered an alert by AV. So this forced us to come up with ways to evade the detection. One way that we've done this, or a couple ways that we've done this, on the left-hand side, we add some random string variables just to kind of break up the code and break up the bytes in order to change the file hash. So if there's a detection based on the file hash, that will evade that detection. And as you can see, we're big fans of Godzilla. Another thing we did on the right, you'll see we actually break up that base64 encoding. So since that's exactly what triggered the detection, we want to break that up into different string variables and then concatenate them together. Therefore, the detection on the whole chunk of code is no longer valid. So in addition to the malicious macro for this campaign, we've also implemented the payload that is dropped by the macro. So this payload is the first known backdoor for Microsoft Exchange servers. And this APT utilized DLL sideloading to load this backdoor into the address space of the Microsoft Exchange application. So taking a look at the .NET code, as we mentioned, we do strip out the malicious part of these samples that we get, and we're left with the benign, one might say declawed functionality. And here we showed two main IOCs, which are extracting the web helper DLL as well as the task scheduler DLL. And I'll hand it off to Andrei.
Thank you. We looked first at the Turla backdoor. Right now we're gonna focus on WinNTI backdoor. Probably some of you know this WinNTI backdoor has been known for, I think, starting on 2013 on the Windows side, but relatively recently was discovered for Linux as well. So what we tried here with the backdoor was to implement the functionality and implement unique functions specific to this backdoor, and of course IOCs. And on the next slide, we're gonna go through, for example, some of the things that are implemented that we've done. So right now, the backdoor has some encrypted API names. And as you can see, because the backdoor is written in C, each time we actually write something, we're gonna keep the same language as the original malware. We've ported those as buffers in C. So all the encrypted names were basically, we copy the bytes and imported them as buffers. Next slide is gonna show, if you go back one, please. Yeah, this one basically shows the function which does the decryption of those API names. And in this case, the malware author named the function X, which exactly how we actually kept the name. And then we reversed, in this example, the decryption function. The decryption is just a basic XOR with FE as a key. And then, basically we ported that to C. And then if we move to the next slide, it's an example, as you can see on the left-hand side. Basically, that's an example of how a profile command file looks like. In this case, this is a simple one. It will just upload our executable, set the executable bit and run it. And this is a simple one. We have more complex one, which will run a series of commands or executables. And then on the right hand side, you can see it in action. When it runs, it tries to basically decrypt the data, resolve the API names, get the addresses, and so on. And then it's gonna do more stuff specific to the WinNTI backdoor. Now let's go through another profile for another malware related to APT groups. This one is called Canon. What's interesting about this one is it's using email as a C2 channel, basically POP3 and SMTP, to connect, get information, and exfiltrate data. You probably, so as Jesse mentioned earlier, copycat is actually just a basic reverse TCP. However, all the other things like exfiltrating data through email, DNS, or all the other things are based on what different malware are doing, what techniques they're using based on whatever campaign we've analyzed and implemented. So in this case, Canon is using email as a C2. So that's what we've tried to do. Basically, we implemented the backdoor functionality, and then of course we emulated the POP3 and SMTP comms as long as specific IOCs. Now, if we go to the next slide, as compared to the other one, which was written in C, this one it's in C#, so makes it much easier to analyze and get data, and then afterward emulate it. In this case, this one sets a persistence in the registry, and then if we move to the next slide, we're gonna see the focus for it was that we basically were trying to emulate the email comms. On the left hand side, you can see the POP3 emulation. So what this one does, it keeps so basically the malware has some hard-coded credentials inside, like username and password. So we kept those, and then we implemented our own fake POP3 mailbox, and as well as a fake SMTP. So with the POP3 mailbox, we let the backdoor login, and then what it will do, each backdoor will have will register with a specific let's say ID, and then it's gonna go through the subjects. For example, it will search for commands for that specific machine. So in this case, we changed the subject to just a red team test email. So what the model does, it goes through the mailbox, sees, okay, is there a message for me? And if it is, okay, I'm gonna get the message, decode it, and then extract whatever commands. And now, assuming, yeah, some commands are run, and we're gonna see in the next slide what kind of commands it supports. Let's go back one slide. It's gonna send data through SMTP. This one, again, it was the same thing. And oftentimes we actually try to keep, let's say, the same domains, or basically domain names. But we're gonna change the traffic in such a way, either to redirect through different methods the domain to a machine that we control. Okay, and then on the next slide, we're gonna see, for example, some data that is able to send, basically a lot of OS information data. And then besides that, also it's able to send screenshots, which are saved as bitmaps. And then on the next slide is just an example of basically the emulated declode malware running. On the left-hand side, you can see it connects to a POP3 mailbox, and it will try to get specific data for the backdoor. And then on the right-hand side, it actually exfiltrates data through SMTP. And now we're gonna go to another profile called Ave Maria, and Jesse will go through it. Thank you.
Thank you, Andrei. And as Andrei mentioned, let's talk about Ave Maria. So this is another profile that we've implemented. And this one here is reportedly tribute to the Fin7 group. Fin7, if you haven't heard, is also aka known as Carbonac, as well as some other things. They are a very, very successful APT actor out there that has made a lot of money. A lot of times, I think in the last couple of years, if we think about some of the retail or bank getting tagged, may or may not, most of the time may or may not be attributed to the Fin7 group. So anyways, Ave Maria was reportedly attributed to that group. For our goals for Ave Maria, we had two main goals, and the first one was to emulate the UAC bypass functionality that Ave Maria utilizes. And then, of course, the second item is to make sure that we implement specific IOCs. First up, we'll talk about the IOCs themselves. On the left-hand side, we wanted to make sure that we resolve all the different API Windows system calls that Ave Maria makes. So in this instance, you look at our code snippet there, it makes a call out to the RTL get current peb. So we get the process address for that, and we resolve that API. And then we also wanted to make sure that we emulated the dropping the file from the resources within the executable file itself. And so if you look on the right-hand side, one of the resources within the executable was a WM_DISP. And so we, as the malware does, we do find resource on that, and then we also load the resource. Some of the other resources that it also includes is a WM_DISM as well. So we make sure that any resources that are included within Ave Maria malware, we've also done within our declawed version. And then, as we stated, one of the first goals is to emulate the USB bypass. In this instance, Ave Maria utilized a fairly well-known USB bypass now, which utilizes the package manager.exe. And because package manager.exe, when it reads or when it gets an XML file as an input, it calls out to dism.exe. And dism.exe has a known DLL sideloading issue as it tries to load dismcore.dll. And so in this instance, what it's doing is we create our modified code, and we name it dismcore.dll. Then we copy it into the Windows System 32 directory. And then for Ave Maria, we've kept the XML file the same. And for this particular malware sample, it was called eloknac.xml. And we also kept the XML, the stuff within the XML the same. So we input the same XML stuff. For this particular USC bypass, it doesn't really matter what's in the XML. You just need some sort of XML file to pass off to package manager to utilize. But after we've created the malicious or created our XML file as well as our modified DLL, copied it over to Windows System 32, then we call package manager.exe, pass to the XML file, calls that to DISM. DISM tries to find the DISM core.dll, doesn't find it within, or tries to resolve it, looking through its normal paths. And first, it looks within our path of the Windows System 32, sees our modified DLL, loads that, and then executes our code. And Andrei already mentioned this a little bit, but I think some people might have been wondering, why is this so simple? When we were talking about our C2 infrastructure itself, and the beauty of it is, if you look through, Muiruri or Canon or WinNTI or Turtle Dark Neuron, is that we kept it simple because it allows us to really morph the copycat as new APT profiles come out. With every new APT profile, every new technique that's out there, we can utilize those techniques or tactics, and then we can make copycat better and make it more elusive. And so with every new technique comes out, we borrow from the attackers. Like, why not, right? If they've already written the code for us, let's borrow from them and utilize that. And so what we do is then we utilize that to make copycat even better and even stronger. And what's nice is it's constantly changing, it's constantly morphing, which makes it a lot harder for the good guys to try to catch us. And next up, we're going to talk about some demos. Go, Katie.
Awesome. Thanks, Jesse. Okay, so now we'll see our tool in action. So this first campaign that we're running is for Ave Maria, which Jesse just explained. As you can see, the zombie has connected back to RC2, and we have some creative names that are randomly generated as well. So we issued a help command, and this shows all the possible commands that can be run within Copycat. So we'll start off with the get APT command. So if it's just run by itself, it will list all of the different profiles and campaigns that we currently have supported. And we will start off with the Fin7 campaign. And we'll use the info APT command to basically lay out an overview of what this campaign will do when executed on the victim machine. So as you can see, it prints out just an overview of the actions, as well as a link provided to if you want to go and learn more about this APT group. So we also use get APT command in conjunction with a specific campaign to issue that campaign on the victim machine. So we wanted to make this as verbose as possible to print out all the actions it's taking one by one. So as you can see, it's uploaded two exes, and then that implantreg.exe is carrying out the actions. So running our malicious payload. And dropping those DLLs as well as the XML file that Jesse mentioned. And as we mentioned, we strip out the malicious part, and instead of popping a malicious binary, we decided to pop calc. So the campaign has completed, and you can use the exit ZMB command to disconnect from your zombie. And as we can see on the victim machine, all of the files were created and dropped. Cool, so that's our first campaign. Our next demo is for a Linux-based campaign. So the last one was Windows, so this one will be Linux, which is the WinNTI that Andrei explained. So we've issued the get APT command to identify all the possible profiles and campaigns again, and then we're issuing info APT on the APT17 profile specifically. So it's a campaign on Linux using the WinNTI backdoor, as we mentioned. We kick that campaign off, and we'll see on the right-hand side when those files get populated. And we can see that that was dropped. Sweet. And our last demo, which is going to be a little bit different. So the first two demos and most of the campaigns we talked about today were pretty in-depth. They involved doing a lot of reverse engineering and implementing specific IOCs. For this one, it's a little bit simpler. We're testing some different kinds of detections that are based specifically on just file names that are dropped on the victim machine. So this particular campaign is the Grand Crab campaign, which basically just uploads all the files that are, they're all the same names that are associated with the APT, named exactly the way the APT named them. However, all we're doing is just creating those files on the victim machine and then dropping them with the goal of testing the detection on those file names specifically. And those are our demos. Any questions?
Yeah, actually. So one of the question in the chat is, how does your tool compare to something like Caldera?
I don't think we've played with Caldera before. However, we played with a few other frameworks, and most of them actually have all the functionality embedded inside the framework. What we tried to change was basically the framework is something basic, just reverse TCP, like Jesse said earlier. All the crazy, really cool functionality is inside the, let's say, profiles, and then they are specific for each campaign. And we're not trying to implement everything generically, but we're trying to be very specific. And maybe, yeah, either Katie or Jesse can, if you have any other ideas. Or
yeah, I agree with you, Andrei. I just took a quick look at Caldera here, and I think that last statement you said is a differentiation, which is we are looking at existing and the real attacks that are out there, and we're reverse engineering those. Versus Caldera looks like it runs through the attack framework, the MITRE framework, and tries to emulate certain things, but it actually doesn't actually take real life ones and try to attack existing systems. And I think that's the major difference between ours and Caldera.
Okay. And
one other thing was we're also trying to, when we do this, for example, when we try to emulate different APT groups, we can also, for example, do it directly on production, because everything that we do is designed to not be malicious. The model is declawed, we emulate everything, and so on. So yeah, that's another thing.
The next question was, any plans to add Astra Roth attack chain to Copycat?
Oh, which one can you?
Astra Roth.
I think we
actually have
that implemented. Yeah.
Oh, cool. Okay. Well, it's like the kind of questions that are good to have. It's like when you already have it.
We have a lot of APT groups implemented there.
Nice. What about Richard Johnson? Is it an APT group? I saw it in one of the.
It's a document name.
Yeah, it is. This one. Yeah, it's just a document.
Is it based on the reverse engineer, or is it just a random name?
So it's straight from the report when we looked up this particular APT group, and then found the report on exactly what they use. Yeah, it's the same name that they used in their campaign.
Next question was, is everything including targets, choosing, and email sending automated?
Yes.
Oh, pretty cool.
The short answer is yes.
Nice. Well, the next one is not really a question, it's a comment. It's damn, this is amazing. So I guess it's a good one. Yeah.
Thank you.
And last question is, will it be open sourced?
That's a tough question. We're lucky we're allowed to present even this, I would say. Well, kind of joking, but the thing is that we're trying. So we will try to talk to our management to explain this would be very useful to a lot of people, a lot of companies out there. To see, okay, what's exactly their state? Can they protect against this adversary or another adversary, or basically all the adversaries for their industry, and so on. And we know this would be very beneficial. So yeah, that's something we're gonna definitely try. What do you guys think, Katie, Jesse?
Perfect response, Andrei.
Thank you.
Yep, sounds good.
Cool. Well, the last comment in the chat is sweet. This was a great presentation. Thanks, guys. Looking forward to the slides. Cool. Well, thank you all for that presentation. I'm glad you managed to get the authorization to speak then.
Yeah, thanks.
And yeah, same thing. Looking forward to the slides. I will send you an email after on where to push them on the GitHub. But yeah, hopefully, like you will get authorization also for the tool. It looks pretty interesting.
Thank you very much.
That's good. Thank
Awesome.
you.
Well, thanks.
Thanks, everybody. Stay safe.
Bye. And our next speaker is going to be Charles. And next and last speaker. So
Social distancing, you say? The future is watching. Welcome to OpCode Virtual Summit.
cool, and welcome back to the virtual summit of OpCode. I hope you guys are having a great time. I see more and more comments in the chat, so that's pretty cool. Thanks again for participating. So far, it's going pretty good so far. Thanks also for the feedback. So, like I said before, this is the first time I do this. So, and we are live, so like some issues were expected, but feedback is greatly appreciated and more than welcome. If there is anything, Ryan is pretty funny. Yeah, we can shoot one together if you want next time in a data center, you know, like we just look at some laptop and we dress like that, you know, like back when Charlie Miller and Valasek were like going on stage with tracksuits. Oh, cool. I'm glad you guys appreciated the last presentation. Very cool. And again, if you have any like suggestion of talk you would like to see for the next edition, since it's going well so far, like there is 80% chances that we will have a next edition. And yeah, oh, awesome. I'm glad you guys are having a great time, and I'm glad that people from everywhere can watch it also, because one of the problem also I was having with OpCode is every time you're kind of limited with who you can bring, but more importantly, who can attend the conference. And it's very difficult to be, you know, to have like a conference where you can actually like attend and get value too, because I mean, now there's so many like conferences that it's very difficult to like pick which one to attend. Personally, I totally stopped to attend conferences because it's just taking so much time, and a lot of the time there is not much value out of it. And even every time I'm in the review committee for conference, most of the presentation could just be like a blog post, you know. So you're like, okay, like is it really worth going to conferences? So I'm glad. Yeah, some of you are watching like that presentation from your couch, from your bed, from your desk. That's pretty awesome, actually. Yeah, thanks again for attending. And yeah, so we're gonna get our next speaker. So with Charles, and who is based in Nairobi. And let me get that one. So. And yeah, that's should be it. And okay, all good. It's your turn, Charles. I will get the stickers and T-shirts. Yeah, that's a good question. Actually, I guess we could just put them on the GitHub, and you guys could like print them at home. You know, since no one can really go out, and we all have to stay at home. But yeah, so. Yeah, so next speaker is Charles from Nairobi. Thanks again, Charles, for accepting to speak. And yeah, it's your turn, Charles. Let me check if you're properly unmuted. Yeah, I think all good. Yeah, perfect. Awesome.
Okay, guys. So welcome to my talk. It's called Black Box Reverse Engineering, and I'll basically be talking about how I do reverse engineering on SOCs. My name is Charles Muiruri, and that's my handle. I crack the code. Who am I? I am a security researcher at Azimuth Security. I'm a mentor at a local innovation hub that's called Future Innovation Hub. I do like ODAs, and I'm deep into vulnerability research, reverse engineering, and exploit development. So this talk will mainly focus, will act as an introduction to most of the guys who want to start doing some reverse engineering, especially on software chips, firmwares. And I will be taking guys through my personal, the steps that I use. And the main agenda will be primarily, we will focus on SOCs. And I have divided the talk into two sections, static analysis, and we later on discuss about dynamic analysis, just briefly. So in static analysis, we'll try and understand, or I'll take you through my thought process and how I try and understand, try and gather information about what I'm working on, understand the firmware I'm working on, and try and see how I can load whatever I want, and eventually how I figure out how everything is created based on the tasks. And later on, I will also discuss why debugging abilities are important and firmware emulation. Again, this is based purely on my personal methodologies in my thought process, and any other approach is still valid, still works. But this is a journey about how me and how I try and think through when reversing stuff. So I basically define black box as anything that is proprietary, closed source. That means I can't find any form of source code out there, and I have zero knowledge on the target, or rather the firmware that I want to look at. I have no understanding of I don't know the architecture. I'm not sure about the loading points. Basically, it's a complete green area. And also lack of symbols, which means that even if you load it straight up into something, into a disassembler like IDA or Ghidra, you still won't understand what's really happening. Then, we have no source code or any leaks whatsoever. So the first thing that I try and do is try and identify sources of information. Now, this is important because you want to gain as much information as possible before you can even, start loading things into stuff like IDA. For me, I always say that that's the last step, because there's so much that has to go. There's so much stuff that you have to do before you actually even load anything into a disassembler. So the first thing that I normally look at is data sheets. I try and understand the chip from an engineering point of view, because that's what data sheets provide you with. They basically give you specifications, and they give you, they are able to answer some technical questions or give you some technical answers, but mainly from an engineering point of view. You might have, a diagram of the board itself, or you might have you might have some information that gives you details about the architecture itself. And that will be important when you in later steps. Then the next thing I try and do is basically try and find platform-related source leaks. And the reason I'm saying platform, in this case, I'm purely making the assumption that whatever I'm looking at has no source code or any leak whatsoever. So the nearest thing to that is a platform leak. In this case, when I'm saying platform, I'm thinking about something like if it's an Android device, like if there is a leaked source code or the kernel source code for that specific device. And this is important simply because it helps me understand how the SoC will communicate with the main processor. In the case of Android phones, or the majority of mobile devices, we have the application processor, which is like the main processor. Then we have other chips that do communicate with the application processor. So in this case, you will want to look at these links or any kind of source code that you can find out there that will give you some insights, no matter how shallow it is, with regards to how this tool will communicate. Then the second thing I try and look at is previous presentations and research papers. Now, this is also important simply because they give you some insights on the topic. They also highlight possible challenges, and this is critical, especially when you want to avoid rabbit holes later on. Simply because you do not want to find yourself looking at a specific area and you have no idea you end up in a rabbit hole. So for that simple reason, I always try as much as possible to identify the challenges within given talks so that I avoid these rabbit holes. Then obviously it gives you a really good head start and helps you get some of the critical information that you might need. Finally, I try and get the firmware itself. Now, this is important because ideally the firmware is actually the source code, or rather it contains the code itself. It could contain various segments or rather various sections, but ideally what you really want is inside the firmware. So it could contain some strings that might give you some hints and might help you in understand what is happening. But as I personally say that that's just like 1% of the whole thing, because example, you might have a string that is just saying something like pre-insertion something. That does not really give you much information. However, it might give you some small insights onto what happens. Then at this particular stage, through my thought process, I have a challenge, and that is how will I end up loading this particular firmware onto the chip, and do I have the firmware? And this step is super critical simply because in some cases you do find that actually getting the firmware of the firmware by itself is a big challenge, and you might have to probably dump the memory of the whole thing, but that is in some rare cases. So once I have the firmware, the next step is now really understanding the firmware. Again, this is all about the thought process, which I believe is critical in any form of research. So there are three main approaches. There are three main scenarios that I have personally observed with regards to firmware headers and their structures. In the majority of cases, you will find like the first few bytes contain some form of firmware header, a small description of the firmware itself. In most cases, they are forming things. There's the size, there's probably the name, there's probably something like the loading address, and there's also probably something like a match. When in some cases you are so lucky and you just realize that the whole firmware starts, the whole firmware just starts from offset 0. So that in such a case, you're lucky because you don't really have to do a lot of the hard work with regards to trying to understand the firmware structure. Then, in the worst case scenario, you have an encrypted firmware. And this could be challenging, especially in scenarios where this firmware is being copied over to, this encrypted data is being copied over to, let's say, a trusted execution environment, and all the decryption is happening over there. And in such cases, you really have to do all the hard work, trying to first of all understand how the decryption is happening. But such cases are rare. However, they do exist. Then the second thing is the other option you could try is trying to reverse the loader, or rather the driver. So in the majority of cases, you'll find that there is a loader that, or rather there's a kernel module that basically loads your firmware onto the SoC, onto the chip itself. And this is done by, this is probably done during the boot stage, during the boot stages of the whole system. Let's say in the case of an Android device, for example, you could have the kernel loading up, having a specific model that just loads up the modem, that copies the modem firmware onto the chip, onto the modem chip, and fires up the modem. And so again, this goes back to the knowledge that we got about how this specific chip would communicate to the main application processor. And in the majority of cases, once you get like this such a kernel module, it also helps you in understanding important details such as how the kernel, or rather how things are loaded within the chip itself. Now the next step is, I try and identify the loading address. Now this is important and very critical, because you want to put yourself in the shoes of, as I would say, the chip itself. You want to understand how things are being loaded onto the chip side. You want to understand how how the chip sees things, and you can only get a clear view of everything only and only after you properly load everything. And this could be loading it into your favorite disassembler, could be Ghidra or either, whichever you choose. And this is key because you want to avoid, again, going into wasting a lot of time trying to figure out which is the correct address. And such information could have been provided by the previous step. That is why having a systematic, or rather having a systematic or procedural way of thinking through how you reverse stuff is critical. So in some cases, example in ARM, there are some tricks that you could use. Like you could locate the exception vector table. Yeah, in some cases, there's always a jump to the EVT entries, or it's just on top. This depends. But in most cases, in ARM-based firmwares, once you locate the exception vector table, then you probably have the correct loading address. Now, so at this point, we have the ability to load everything correctly. We have our firmware loaded up well correctly onto our favorite disassembler. Now the next step is simply trying to understand how once the firmware is loaded, what next? So the firmware has to start a few things, and most SoCs implement a runtime operating system, and this uses a lot of tasks. So in most cases, or rather the majority of cases the majority of firmwares that I have interacted with, always have some form of task creation. Now tracking down these tasks task creation and functions is critical, simply because they enable you to understand and see where things start from. And the way most firmwares do it is by having task creations for different protocols or core functionalities. We could take the example of a modem. Let's say, for example, it will create a task will be created to handle anything that relates to calls, handle anything that relates to, say, SMSs. And by tracking this, or rather identifying these task creation mechanisms, you will be able to understand a little bit more about the system. Now, strings might be very helpful here, simply because you might have strings that probably give you, like error strings, or you might have just simple login strings. I personally categorize strings into main categories, and that is debug strings and log strings. And for me, a debug string is basically, any string that provides some form of debug information. Could be an error type, could be a function name, could be, like a function, the way a function like function and its arguments. And the next one is a log string. And this is just something that is just logged. It's from, that it doesn't really help with regards to debugging. It's just logged. Could be, just an output of the result of something. And the main difference between these two is the debug strings are more verbose compared to the log strings. So you will probably get more information from the debug strings compared to the log strings. And in some cases, you will find that in some firmwares, they will end up disabling the log, anything that I will categorize or will be categorized as just a log string, and enabling the debug strings, or rather the debug prints, simply because it's also useful for their engineers when they are doing, when they are trying to analyze crash dumps and trying to figure out where things went wrong. Now, as I said before, strings might give you just shallow insights to me, and mainly with regards to these systems, or rather mainly with regards to firmwares such as the modems, Wi-Fi firmwares. This is probably just 1%, or rather, to be fair, I would say 5% of the whole thing. And to me, it wouldn't qualify at all as reverse engineering, because there's a lot that you would need to do before you would even, so before you say like this function does ABCD, you need to do a thorough analysis of the function itself. So strings purely, to me, does not qualify as reverse engineering. Now, so at this specific point in our thought process, we have everything loaded up. We have identified the tasks. We have identified the task creation mechanisms, and we are at a point that we want to proceed further in our research. And first of all, we need to identify a research surface. In other cases, depending on the purpose of the research, you could also call it an attack surface. But for this specific case, we will call it a research surface. And this is an area of interest that specifically meets your research scope. Could be anything, could be a surface that purely does, an OTA operation, that is an over-the-air operation. Could be anything that is completely remote, or could be anything that is completely local. And this just depends with your research scope, and it has to be in line again with your purpose and your research goals. So sometimes you might find you just bumped onto some really cool surface, but again, when you check and you look at your scope and your goals, it doesn't align. So it's always good to just focus onto the goal of your research. Then from there on, the next step is identifying entry points to these attack surfaces, or rather our research surfaces. And these again will be critical. You will be able to identify it based on the results you got previously by identifying task creation mechanisms. And as I mentioned earlier, let's say for example you want to focus on anything that does, let's say, an OTA operation. You will focus on things that require probably zero user interaction. And since you already have discovered that, like let's say call creation is started by this specific task, So you will eventually just narrow down to that specific point. Now, I mentioned the debugging abilities. So as at this point, as an add-on, you will probably want some debugging abilities. So this is essential, especially when you want to understand the state of things when a given operation is happening. You want to understand how things look like at a given specific time and points. This is very useful, especially when you're performing memory analysis. For example, you want to understand how your heap looks like when you're doing heap-related stuff or other memory-related operations. Now, debugging abilities, again, will also be critical when you want to apply things like hooks, which will definitely help you, read stuff probably out of memory in the case that you don't have that ability already. And firmware emulation. So this will probably be the last step for me. And I only do this in cases where I realize I don't have a device or I don't have access to something that is running my target firmware. And firmware emulation is important simply because it tries to answer three main questions, and that is when does something happen? Then why does it happen? You want to know when does it happen? At what particular point does this function? At what particular point is this function called? Why does it happen? What are the why does it happen? This basically tries to answer the question. What would lead to a given function being called? And finally, what are state of things when it's happening? So this tries to answer the question that of how do things look like when a given operation is done or implemented. Now, at this particular point, I now purely focus on once all of this is done, I now purely focus on bug hunting and vulnerability research. And yeah, and that is the end of my short talk. Yeah, I think questions are welcome.
Awesome. Thank you, Charles. Let's see if the chat has any question. Quick question while we're waiting for the chat to give one. At how many platforms did you look at for that thing?
So basically, this is my thought process, or rather the thought process that I have been using for quite some time. And I have been using it on a bunch of platforms. I would say when I'm reversing Wi-Fi chip, when I've done Wi-Fi chip reverse engineering, modem, and yeah.
And Wi-Fi chips for routers, this type of thing, or?
No. So this talk was mainly focused on the mobile realm, which is my area of specialization.
Okay. Like baseband stuff, or not necessarily?
Yeah, so baseband stuff. So any chip, or rather any embedded system that is within the phone, that will basically include mainly the Wi-Fi chips and the baseband chips.
Okay. And someone in the chat is saying, I'm here for the exploits. So I guess people are expecting to see some exploits here. Charles, what did you do? Like you're breaking the heart of some people here.
Next time there'll be some, hopefully. Let's see.
They're like, okay, come on, you are like supposed to represent Kenya. What happened to the exploits?
Hopefully next time.
It's like Stella Magana is saying a quick demo appears. So I guess like people are getting curious. Another question was, are you wearing pants, Charles? From Gabriel Mutange. And one of the question after from Lorna Monyangi is, when doing firmware emulation, can one be able to get the chip-specific bugs?
Well, so I think if I understood correctly, is she's asking whether you can find bugs when you're doing firmware emulation. I think I will say it depends, but I don't think you will just find bugs by simply running emulating a firmware. I don't think it's possible to just find a bug by running a firmware. You have to actually do some, like code analysis of whatever the firmware itself, so that you can find vulnerability in the firmware. And probably you can emulate. You can use the emulator to try and see if you can hit the vulnerable function.
I see. Yeah, because another question was, how does he emulate the firmware? Are you using things like your, what's the name? Is it Unicorn emulator or?
Yeah. So I'm a favorite of Unicorn. Yeah.
Cool. Is this the main one, or is there like any other library that can be used for emulation?
Well, that's the main one that I normally use, I think. But again, it all depends with the one you want to use. But that's the one I'm familiar with mainly.
Cool. Laura Tish is quite enthusiastic. She's like, thanks, Charlo, for once I understood everything you said. No floating today. Good one, Charles. Christian Kisutsa is asking if you have any tips for setting up a firmware analysis lab for beginners.
I think one of the main things that you probably need is depends with the firmware you're looking at. Probably you would want to set up an emulation environment. If you want to look for some bugs and you will probably want to write a small fuzzer for that too. And I think those are the two main things that you probably need, and also probably an environment that would work with a specific firmware that you're looking at. So, for example, let's say you're working on the baseboard chip, you probably want to set up an environment that would emulate a base station.
Okay. Another question from Joxean Spellman. Have you found certain platforms to be harder than others? Qualcomm versus Huawei or Samsung, for example. I guess he's asking for tips of platforms you should look at.
Yeah. So as far as I can tell, all these platforms always end up being different. So in the case that you look at, let's say Samsung, it's completely different from what you will see in, let's say, MediaTek devices, and both of them also are completely different from iPhone devices and Huawei devices. So since all of this, it's usually proprietary, so they are always completely different.
So no platform being harder than others, like for instance, because I know Samsung did a bunch of security work. They hired a bunch of security people. So would you see more mitigations in their platform compared to a Huawei, or not really? Because I guess with firmware, the main problem is unlike operating system, where you would see vendors, for instance, if you look at Microsoft or Apple, they have huge team working on mitigations and bug patching, but many mitigations where it changes with each platform. So is there anything similar with firmware, or not at all?
Yeah, so there's something similar, and so again, the complexity always is always different. in some cases, you might find the hardest part is actually trying to get the firmware itself. And in some cases, the hardest part is the mitigations, that have been implemented from the, in the firmware itself. So, the levels of hardness totally depends and totally are different depending on what you're looking at. But it is the same. And I would say, especially for like the last 3 years, or rather the last 2 years, I have seen some major changes and implementation of mitigations into firmwares.
So does that mean they finally have stack cookies to avoid like stack overflows? Or?
Yeah, so in some cases you will find stack overflow detection. Some cases you'll find SLR implemented. Yeah.
Okay, and let's see if there is any more questions. The presentation. Joxean is insisting. There was no answer on the Pence question, so I think like the audience is in like really wants to know. Great. Another question. Any hypothesis why MediaTek keeps getting on?
Oh, pardon?
I guess the question keys. I guess it means keeps. Any idea why MediaTek keeps getting on? Like why? Apparently, like MediaTek, I guess, is having more vulnerabilities than any other platform.
Oh yeah. So I think, well, this is probably my thoughts. I just think it's because they are not. They have. Previously they were not that security oriented, and that is my thought compared to other vendors, compared to something like Samsung, where in the case that there's a new a patch out, they try and put that, or rather implement that in the next rollout. On MediaTek's side, you'll find that there is some delays, there is some, they are slow in implementing stuff. Again, this is based on how I see stuff, so it will be different, but yeah, I think that's the main reason. But that has started changing recently, especially due to more people have started to look at the specific area.
And what about MediaTek? Where is it based? Is it a US vendor or Asian vendor?
I think it's an Asian vendor.
Oh, is it Chinese?
Yeah, I'm not sure.
Okay, interesting.
But
okay,
I know
cool.
it's Asian based.
And that's the main firmware being used in Africa, right? If I remember correctly.
Yeah. So the majority of phones do run on the MediaTek platform, simply because I think they provide cheaper. They're cheaper. Yeah.
Okay, that makes sense. Cool. Well, I guess I don't see any more questions. Yeah. Well, thanks for your presentation, Charles, and it was pretty good. Yeah, don't forget to send me your slides after, and then
sure.
Or you can just do a pull request. I think I should just send an email to explain how to do that. And yeah, awesome. Well, thanks, Charles.
Guys. Thank you.
Social distancing, you say? The future is watching. Welcome to OpCode Virtual Summit. Indeed. This is a fake background. Yeah, basically the studio is in my bedroom. I didn't really have time to clean it. I was like, you know what? It's probably going to be easier to just like use a green screen and make it look like I have a clean desk. Otherwise, Nicola, you know better. Like having a clean desk is not a very easy task. Okay, so someone is replying in the chat that MediaTek is a Taiwanese company. Interesting. So they're not Chinese, I guess. And oh, interesting. So NSO has been targeting MediaTek quite a lot. Interesting. You guys have more information than I do on that one. I would not know, but very interesting. It would be interested to know where you got that from. But yeah. Well, I hope you appreciated today's conference. So, like I said, it was the first edition. And I think very likely we're gonna have another one. I was just talking with another like potential speaker. Maybe we'll do like a session, a live discussion on disinformation, because there's a lot of problem with disinformation now, and with the coronavirus. As you can see, it's quite hard to know what's fake news or not, and even like politicians are kind of struggling, and then you have governments creating their own feeds, and even a lot of that, they kind of relay like some unreliable information. So we still have to decide of the date. We just got decided like, I don't know, like 30 minutes ago with a friend. And yeah, so it should be around disinformation and disinformation. And yeah, so that's it for today. So the presentations are going to be available on GitHub. And yeah, if you have any questions or suggestions, like, you're more than welcome to send me a message on Twitter or send me an email. If you want to speak in the next edition, you can apply. You can apply to the call for paper, which is still open, and I think it's still gonna remain open. And whenever there is enough presentation, I guess we can kick off another like session. And no, it won't be made into individual videos. Someone was asking. It's just gonna be like the live stream like this being posted, and that's pretty much it. But yeah. Okay. You can message me on your sources. But yeah, that's it for today. Don't forget to subscribe, so whenever we do another live or post another video, you can be aware of it. Yeah, we were around 100 viewers today. I'm quite surprised, to be honest. I would not have expected to have more than 10 viewers, but I guess it's a good surprise. And yeah, since we are all locked down at home and kind of forced to stay at home, because I know some conferences were thinking of just doing like some volatile studios where like they will invite speakers, but like now most of countries, people cannot even leave their house. So if you have an external microphone, that's pretty straightforward. And yeah, so I guess maybe it's an interesting format that would be that I should keep alive. Yeah, if you think I should do another one, that I should keep it alive, yeah, just drop me a message. And yeah, don't hesitate to recommend that video to anyone after. And yeah, that's pretty much it. So thanks again for listening today, and hopefully see you soon. And yeah, talk to you on Twitter, I guess. Bye, everyone.